Hey guys, how's it going? Today we're looking at +1, which is a LeetCode problem. It's not just any LeetCode problem though, it's a math problem. And the concept is concerning the digits. So in math, you have different places in the number. So you've probably heard about the tenths place and the hundredths place. But today we're just concerned with the ones place and the tens place and the hundredths place and the thousandths place. And so that's basically what this problem is concerned with. Let's look at the problem statement, So this problem is problem number 66. I'll go ahead and read it. You're given a large integer represented as an integer array digits, where each digit is the ith digit of the integer, and the digits are ordered from most significant to least significant in left to right order. So that means basically the least significant digits are on the right side and the most significant are on the left side. So it kind of goes back to what we were talking about here. Of course, the ones place is it's not significant. None of us are really significant if you think about it. Anyway, so I'm gonna keep reading. The large integer does not contain any leading zeros. So basically, let's look at an example. So here we have the example. Right, so let's look at example 1, It's gonna be okay. So digits is 1, 2, and 3, and it represents the integer 123, and incrementing by 1 gives us 123 plus 1, which is 124, but you knew that. So the result is an array of the numbers 1, 2, and 4. And so yeah, each element just represents like the hundreds, tens, ones place. So if we go back here and we look at this again, you can see that we got the ones, we got the tens place, we got the hundreds place. Oh man, we're gonna get through this. It's gonna be okay. So the result of this is that this is the ones place, this is the tens place, this is the hundreds place. But if you go back to the problem statement, oh God, okay. It says does not contain any leading zeros, so basically that means the number we're given, we're gonna have to dynamically add new numbers to the array. So if you've never done that before, it's not, well, it just means you gotta learn about something. And that thing you need to learn is right here. I got it for you. Don't worry about it. This is coming from the website MDN Web Docs. So basically, you need to know about this method. It's called unshift. And the unshift method of the array adds this, it takes elements as an argument, and those elements will be added to the beginning of the array. And it says that it well, basically, if you do this, if you, for example, if you here's your array 1, and your array is 1, 2, and 3. Well, let's say if you called the unshift method, and you passed in 4 and 5, it's going to return the new length of the array, and the array will contain the new elements at the beginning. So you can kind of see the elements are out of order here, because we added them to the beginning. So you have 1, 2, 3, and if you have your array and you call unshift, the numbers that you pass in, and you can pass in more than one if you wanted to. And if you did that, the array would be updated with the new elements. And so tying this back to the problem at hand, you can see that we have the ones place and the tens place and the hundreds place. So basically we have this this concept that we need to think about, where each element is only from 0 to 9. And if we add 1 and the array is just this single element, 9, then we have to carry the number somehow. And so if we find that the number is 9, we have to turn this element. We have to update the element to make it 0. But not only that, but we're going to need to use the shift method because we don't have an element. There are no leading zeros, so we're going to need to, here, it's kind of written over here, isn't it? So over here you can see digits dot unshift 1, and basically this line of code, all it does is that. That's all it does. So it's you can do it too. You can do it. So I believe in you, and yeah, so that's how you go from 9 to 10. And so this concept is important to internalize because you're going to need to dynamically change an array at some point in your life, and you can do it using the unshift method. So well, let's look at this problem. So we have digits. Okay, so this is what I have for digits right now. It might change later. And what's happening here? So we have a for loop, but it looks different than what I've seen before because normally the for loops I write, they go forward. They don't go backwards. So this one, it looks really strange. I've never seen anything like this in my life so far. So, but I guess the concept is kind of easy to understand. So, we're going backwards. So if we did a normal for loop, it would be something like let I equals 0, I less than equal to digits dot length I plus plus. But kind of this time we're going backwards. So the starting index that we want to start counting from is the last number, and we have to remember that computers count from 0. So this is index 0 and this is index 1, and so we want to look at the last index first, right? And if we just ask the computer, hey, what's the length of my array? It'll look at this and it'll say something like, 2. And you'll be like, 2? What? And it'll be like, yeah, 2. And you'll be like, but I want the last number. I want, give it to me. And it'll say, no, all I'm going to give you is the length. So you gotta kind of, you gotta struggle with it. You gotta demand it. You gotta assert yourself, because that's life, dude. You gotta assert yourself, and you got to tell the computer, give it to me. So let I equal digits dot length minus 1. So 2 minus 1 is 1, which is the index. So we want to start with this index, right? And so that's good. And so we're going to look at the number. We want to access the element of the array at that index. So again, we use square brackets. I don't know why I said again. I'm just saying that for the first time. And so here we have, so basically this is the array, square brackets, and then the index. And so right now, that is 0. So 0 plus 1 is 1. And that does not equal 10. And not in any math classroom that I've ever been in. And so we increment, we use 2 plus signs in a row, which just means that we add 1. And so we're going to, let me write this down. We're going to add 1. Okay. So we're going to add 1 and return the digits. So, and then we stop. That's it. That's all we need to do, right? So, in this case, it's actually pretty simple. But it can be kind of complicated. So let's go back to our examples. Yeah, so if we had 9, we made it 10. But some of the edge cases that they're gonna come at you with are gonna be pretty brutal, dog. And it's gonna be like not chill, no cap. So so we just got to be ready for that and not take it personally when it happens. So, oh shit. I want to redo. There we go. So, okay, that's what I want. For example, if we have 99, well, what if we had 999? So let's look at this, huh? This looks very complicated. But somehow we will come to understand this in time and in patience. Humans are persistence animals. So you got to chase down your dreams until they get tired and lie down. And okay, so we're given, this is digits. And remember, like we said, got the ones place, the tens place, the hundredths place. And what happens when we add 1? Well, it's going to be a lot. A lot is going to happen. And you just got to be ready for it. So let's look at this. Let's trace the execution for 999. Oh my god, sounds like Hitler. Okay, Hitler's scary. Here's a dog. Uh-oh. Good, good, good. Okay, I feel better. So first off, we start with the last digit. I is digits.length minus 1. So it's this one. And if we add 1 to 9, so this is the array and the index. So the value of the array at that index is 9. It's a really... Okay, that's fine. So if 9 plus 1 does not equal 10, but it does equal 10, right? So what do we do? So this if statement does not 9 plus 1 does not equal 10. So 9 plus 1 is 10. So the result of the math on this side of the operator, the result of this math is 10. And so 10 does not equal 10. Well, if you think logically about like Boolean, Boolean, that guy from history from a long time ago, the guy who invented truth and false, Mr. Boolean guy. Well, if he were here right now, he would tell you that the statement 10 does not equal 10. Well, hate to break it to you, but that's false. That's a lie. And sometimes people lie. And so if 10 does not equal 10, well, that's false. So this if statement, guess what? We don't do it. So what do we do? So we go down here, and the current index, which is still this one, it becomes 0. So 9 becomes 0. And if I is... Oh, shit. That's wrong. I'm sorry, guys. I got all caught up in a way. And so this is index 0, 1, and 2. And so if I is equal to 0, we'll know what we're looking at here is 2. So we do not return digits. And so we go back to the for loop. And I, if you remember from last time, is decremented, which is a fancy way to say we minus 1. And so we go to this number, and the process repeats again. So 9 plus 1, well, that's another falsy. And so we skip this. Bye-bye. 9 becomes 0. And so 9 becomes 0. And then we get to the if statement again. And I is currently 1, so we do not do this. And we go back and we go here again. And we're at 0 this time because we decremented. 9 plus 1 does not equal 10. No, that's false, dude. What are you talking about? And so, again, this becomes 0. And this time, I is 0, so we unshift and add 1 to the beginning. So our new array looks like that. Okay, guys. Well, that was +1. I hope you learned some stuff. I'll see you next time.